What's up, guys? Welcome to the first video in learning awesome mathematics. So learn mathematics with Wood. We welcome you to the first video in a series of learning awesome mathematics, and of course mathematics is awesome. I hope we can be helpful to you guys. So we're going to explain all the concepts of mathematics from the beginner. We're going to go all the way to advanced, and we hope you like our videos. So please don't forget to subscribe. It helps us a lot. So it encourages us to give you guys a high quality best learning material. So without further ado, we begin our first lesson with awesome mathematics. So first we're going to discuss the atomic and molecular statements. So what is atomic and what is molecular statements? A statement is any declarative sentence which is either true or false, but not both simultaneously. So it can be true and false at the same time. It doesn't make sense. A statement is atomic if it cannot be divided into smaller statements. Otherwise, it is called molecular. So you guys cannot divide the atomic statement. Cannot be divided into smaller statements. Otherwise, it is called molecular. So the difference between atomic and molecular statement is a statement is atomic if it cannot be divided into a smaller statement. That's atomic. Otherwise, it is called the molecular. So that's the difference between the molecular statement and atomic statement. An atomic statement expresses a single idea. So we're gonna present some examples of atomic statements. The moon is square. So if you guys look at here, an atomic statement expresses a single idea. The moon is square expresses a single idea. Whether it's true or false, that's we're going to show you guys shortly. Michael is right-handed. 15 is a prime number. 5 plus 7 is equal to 15. So there are 4 examples of atomic statements. Alright, so now we begin with the first one. The moon is square. So I'm going to ask you guys, is the moon square? Negative. Our first statement is false. Or I can just write simply F. Michael is right-handed. We don't know. We don't know the Michael. We don't know. We don't even know who Michael is. So we don't know Michael. Michael is right-handed. We don't know because we don't know who Michael is, or even if you know Michael, we don't know if the Michael is right-handed or left-handed. This is we don't know. 15 is a prime number. Is correct. It's true. So I'm just gonna put a true as a T. 5 plus 7 is equal to 15. That's false because 5 plus 7 is not 15. It's 12. So that's false. Our first atomic statement, the moon is square, is false. The second one, Michael is right-handed or left-handed, whatever, we don't know because we don't know Michael and we don't know if the Michael is right-handed or left-handed. 15 is prime number. That's true. Atomic statement. 5 plus 7 is equal to 15 is false because 5 plus 7 is not 15 but 12. And now we're gonna show you guys some examples of the following examples are not statements. Would you like coffee? Go to school. 3 plus x is equal to 15. This paragraph is true or false. So we can say this paragraph is true. Then we can say this paragraph is false. So now we're going to go here to the first one. Would you like some coffee? This is a question because it's not expressing the single idea, but this is a question. So how about the second one, go to school? It's a command. We are giving command for he or she to go to school. So we are commanding. This one is command 3 plus x is equal to 15. So this is not, because this is contains a variable. So the last one is, this paragraph is true or this paragraph is false. It's called self-referential. It's self-referential. So our last, the following statements are not the statements, is that would you like coffee is a question, because we asking question if he or she likes coffee. Go to school is a command. We are commanding he or she to go to school. 3 plus x is equal to 15 because it's a variable. It contains a variable. This paragraph is true or this paragraph is false. Is self-referential. Now we begin with the logical connectives. We build more complicated molecular statements out of simpler atomic or molecular ones using logical connectives. That's a definition of logical statements. Example: Adam is man and 42 is perfect square. That's examples of logical connectives. We use logical connectives to form compound statements. 5 logical connectives are and, or, if then, if and only if, and not. These are the 5 logical connectives. We can break this down into smaller statements. 15 is a prime number and 10 is equal to 20. So you tell me now 15 is a prime number is true and 10 is equal to 20 is false. So true and false is equal to false. Anything that the end comes in between, even if the first one, the false and true, it becomes a false. True and true it has to be true and true, otherwise is negative. The second one is Adam has house, our oxygen is gas. So we don't know Adam, if the Adam's got a house or not. Or the second one is true, oxygen is gas, because oxygen comes into, so it's not a liquid but it's gas. So true, our true is equal to true, even if both of them is true, because the first one we don't know but the second one is true. The first one is false and the second one is true. And because we don't have and but we don't have or, we have or. So the false or true becomes a true. This statements, this one is true. If Mary has a dog, then shark have wings. So that's example of if then. If Mary has a dog, then sharks have wings. So we don't know Mary. If the Mary's got a dog, cat or pet, then sharks have wings. So this is negative. If true, then false is equal to false. If true, then false is equal to false. So even if this one is true and this is false, it becomes a false. So that's the example of if then. George Washington is alive today if and only if 5 plus 5 is equal to 10. So false if and only if true is equal to false. George Washington is alive today is false, because George Washington is not alive today if and only if 5 plus 5 is equal to 10. So this one is correct. The first one is false. If and only if true, then the second one is true, it becomes false. So false if and only if true is equal to becomes a false. 9 is not a prime number. So this is not true, because 9 is a prime number. Not true is equal to false. Just keep in mind, because we are using a not. 9 is not a prime number, because 9 is a prime number. We are using not here. Not true is equal to false. Not true is always false. Statements and truth. So the first one, 15 is a prime number and 10 is equal to 20. Adam has a house and oxygen is gas. If Mary has a dog, then shark has 2 wings. George Washington is alive today if and only if 5 plus 5 is equal to 10. This is the example of the last slide. So we use that and, or, if then, if and only if. They're all binary connectives. Just keep in mind this one's the binary connectives, because they connect 2 statements. Either we are using and, we are using or we are using if then, and we are using if and only if, because they are connecting the 2 statements. 9 is not a prime number. Not true is equal to false, as we said in the last slide. Not true is always false. So this is example of unary connectives. So the first one, and, or, if then, if and only if, is example of binary connectives. And the second one, 9 is not a prime number, when we use not negatives, is unary connectives. Unary connective, it applies to a single statement. Unary means apply to only one item. So this is unary because we are not using the and, or, if then, if and only if. We are just using not. So this is unary connective, and that's a binary connectives. These molecular statements are still statements, so they must be either true or false. To analyze logical connectives, it is enough to consider propositional variables, sometimes called sentential variables. Usually capital letters in the middle of alphabet, P, Q, R, S. Sometimes you see the lower letters P, Q, R, S. We think of these as standing in for statements, but these are two values the variable can achieve, and that two values true or false. We still, in logical connective, we will use letters such as P, Q, R, and S to represent atomic statements. We refer to these letters as propositional variables. We have a symbol for each logical connectives. That's our logical connectives. So the first one, we have and. The second one, we have or. The third one, we have if then. The fourth one, we have if and only if. And the last one, we have not. And that's the symbols we use. This and is upside down V, and with the or we use the V like symbol. If then we use like arrow. If and only if we use the two-sided arrow, and that's not is like a corner of the box or corner of the roof, whatever you guys can think of this. This is a not. So the first one, and, we call this conjunction. The second one is like a V, we call this disjunction. The third one, if then, is arrow sign, we call this implication or conditional in mathematics. And the fourth one, if and only if, with the arrow with the two-sided, we call this biconditional. And the last one, not, negation, is like corner of the roof or corner of the box, is called negation. Now how we gonna read this? P conjunction Q, P disjunction Q, if P then Q, P if and only if Q, and this one is not P. So we repeat again. The first one is upside down, this like upside down V is and. The second one is like a V is or, and this arrow, this guy here is if then, and this guy is here with double arrow on facing both sides, if and only if. Then the last guy here is not, it's called negation. So this the first one is called conjunction, and we read it as P conjunction Q. The second one is disjunction. That's how we put it there, P or Q or P disjunction Q. This one is if then implication. We imply, we say this imply as well, implication. Our conditional, we say P if and only P implies Q. That's how we read in mathematics, but we say if P then Q. Biconditional, P if and only if Q, and then this one is negation, and we say not P. Alright guys, that's it for this video. If you have any question or comments, leave it in the comment box. Otherwise, I'll see you in the second video, and bye.